So let's start with the simple printing today using MEW, melt electrowriting. So today we used polycaprolactone. It's called as PCL. It's like a common biocompatible polymer, and it's also approved by like Food and Drug Administration Department, and it's widely used in a lot of tissue engineering applications. So we're going to use that specific PCL polymer to demonstrate some patents using our MEW. So initially we first what we did is we filled those polymer pellets into the chamber over here, and then we preheated it for a while. So the melting temperature of PCL is around 60 to 70 degrees C, and initially we need to have a higher melting temperature to accelerate their the melt timing. So we used around like 90 to 100 degree C as the temperature initially to melt the polymer and turn it and make it into more viscous like solution, so that we can able to easily pull out those material out of the nozzle. And after some time, once we do the manual pulling, manual triggering over here, we could able to see the polymer like in terms of like fibers coming out of the nozzle. So once we see those kind of like thin fibers, we can able to start with the next procedure. So the very first procedure before printing we have to do is the Z calibration. So we have to make sure what's the printing height we're going to use. So for that we can first we need to adjust the printing bed towards the nozzle, and once we got appropriate like distance, we need to do the Z calibration. So to do the Z calibration, we need to make sure this nozzle comes closer to the bed. So we use this like a thin paper or a thin sheet to know the height between the nozzle and the bed. So first you can see we are just getting down the nozzle close to the printing bed, and once it's pretty close to the printing bed, we could use this thin sheet to see how close the nozzle to the printing bed. So we should make sure the nozzle doesn't hit the printing bed. So we use this paper to just slide it to see if there is any friction between the nozzle and the printing bed. Yeah. So yeah. So now the printing bed and the nozzle is pretty close to each other, and you can see the distance is around like the Z is around 86.4 mm. So we need to take a note of this value. So this is the calibrated Z value. So from this we need to add like 3 mm or 4 mm or how much ever the printing distance we're gonna usually use. So usually in terms of like normal 3D printing techniques, we're going to have a very low layer height, like probably 0.3 or 0.4 mm. But in terms of MEW, we're going to maintain certain distance like 3 mm or 4 mm so that we have enough distance to have the voltage supply to pull the material out and to get a high resolution thin lines. So in our case, we're going to use like 4 centimeter, 4 mm. So from 86.4, we're going to add 4 more value to it. So and we can have like 90.4. So we need to update this value into the G code over here, where it's already set as 89.7. So here we're going to change it to 90.4. So in this scenario, now we're going to say like our layer height will be like 4 centimeter. So from 86.4, it's going to go for 90.4. So the 90.4, it looks like something like this. Let me show you. You can see. Yeah. So I set the distance to 90.4. You can see the distance between the nozzle and the printing bed. So this is the like an approximate like average distance we're going to maintain during the printing, and the voltage. Now we're going to connect the voltage supply to the printing. So this is the voltage, the connections over here. So we're going to connect, we're going to make the printing bed as the we're going to connect the voltage supply to the printing bed, and then this is the voltage supply we're going to use. So it has a capacity of 30 kilovolt, 30,000 volt. So but usually in MEW, the average voltage people usually use is around like between 3 to 8 kilovolt. Yeah, so now you can see a certain distance between the nozzle and the printing bed, and you can see the printing bed moving towards like X and Y direction. And if you take a close look, we have a 5 to 10 second pause at one point, and then from that point it's gonna pull out the fibers to the very end part. So in that, so the reason we're having the like a small anchor point at certain is to have a pretty good like grip, and from there we're going to pull the fibers to a more thinnest we could able to like pull. So in that scenarios we could able to get like a very high resolution, very thin fine lines, and that lines diameter will be around like 5 to 10 microns, which is pretty like phenomenal for like printing techniques like MEW. And this could be this is happen only possible like with the electric field. So without the voltage supply, it's very hard to pull out the fibers. So it's just gonna be like tangled upon if we don't have any electric field. So only because since the printing bed is charged with the voltage supply, we could able to overcome the surface tension and pull the polymer jet pull the polymer jet towards the printing bed, and we could able to stretch the fibers as fine as we could.